Hello, you are welcome to class. My name is Jude Chukwudi Ilobelu, your consultant and your anchorman. You are welcome to the conclusion of our class. We have been able to look into different aspects of data science. We started by looking at some basic important tools of analysis. Looked at advanced Excel. We look at Power BI and the use of Tableau visualization tool, and also looked at database using the structured query language from Microsoft company. We are concluding with the use of machine language vis-a-vis the application of Python, then Jupyter Notebook, and the actual deployment of machine learning terminology and technology. We have been able to look into various notes. So I will be wrapping up in this class. It doesn't mean that I have finished conclusively the work. As a student, we expect you to continue to do research into different work. My work is to guide you and help you when there is challenge, so that it will be easy for you. And also, I will also wait for signal, then I will now give you your final project work, which will qualify you to stand among the rest. So today I want to look at heart disease visualization data sets. Remember, anytime we want to work on a project, we'll have our data sets in hand, which is what we use to have the first view of what we want to do. After having that view, we now go ahead to open up our Jupyter Notebook, and then we begin to code. So for this data, we have our data set, which are going to open up. So this is our data set. So we always look at your data set to have an idea of what it entails. I have my ID. ID is unique number for every customer or every feature and record that is in our work. You can also look at the age. See the start from minimum age 28 up to 77 years. Okay, want to see the top 10. For instance, these are the top 10. You can also go back, look at the sex. You have male and female, 193, which is 21% is female, and 725, 78.9% are male. Okay, there's no blank space, and a unique item is just 2. There's no duplicate. Okay, the next one is chest pain type, and we'll have in coded manner 4 types: ASY, which is 496, which is 54%, ATA 18%, NAP 22%, and TA 45%. So there's no blank. It's okay. We look at the resting B. See, to check if there's a blank. I don't have any blank. So take it okay. Look at our cholesterol. This is the cholesterol rating from the number 0, 85 up to the highest 603. I'm using an improved version of Excel, which has WPS, so it makes my work more easy. Even though they're looking for money, I refuse to pay for the one that will make the work more elaborate. But what I'm seeing is okay for me. I'm enjoying it, so it makes my work easier. I can look at a lot of things. I can filter by color. There's one. I can filter by number, by value. That's what we're doing here. We can do the count, can export and take other options here. Display filter counter, display total counter, amongst others. So it gives me a lot of option. Then we have first string. It's only 0 and 1, not like a boolean. Look at the resting, and it's giving us 3 items: LVE, LVH, normal, and ST. And normal is 60%. It may have a meaning in medical term. Look at maximum HR. This pro feature, if you want to use it, which you are not using, not upgrading, gives you what we are looking for here is to be sure that we don't have blank, and this work ensure does not have any blank. If there is blank, we will now know how to treat missing value. But since there is no blank from what we have seen so far, we will now go ahead. So I have N and Y for this value exercise. Then old peak have negative values up to 6.2. Okay. Then we'll have a ST slope as either down, flat, up. And the last one will have heart disease, which you predict either if it is 1 or 0. That means the person either have heart disease 1 or it doesn't have 0. So this is, we have seen that our work is clean. There's no missing or null value in our work. So we'll go back to our Jupyter notebook in order to have an important visual with respect to our work. So normally the first thing we do is to import the needed libraries for our work. So we import pandas. We know pandas is for data manipulation, among others, to make it look nice and fine. We import NumPy for mathematics. We use Seaborn for visualization, better visualization. Matplotlib inline is for also visualization. We use different type. PyPlot as PLT. We have also style. We bring in Plotly Express, which is mostly what this work used. It's a form of visualization that has its own unique character and quality. We bring everything here is what we want to use. So by the time we run it, it will run into memory. So let me start by going to the kernel and clearing every output. So this is a demonstration work. In the real time, on the real world, data science work does not go smooth like somebody swallowing semovita with ogbono soup as you're taking is going straight. It doesn't happen in data science. There's a lot of intrigues, a lot of checking, a lot of balancing over the time, over months, over years. the particular tool you have used may become deprecated, such that it cannot be applied as it was applied initially. Secondly, data scientists is a community. We borrow idea from different community. Remember, in knowledge synthesization, we use knowledge from different classes and continue to build. Some of the coding we are using was not developed by us. Have it in your mind. It is a code that somebody has run and the code went well. So what we'll do is that we'll copy that code and we'll bring it to our work and see if it can run with our work. If the code does not run with our work, we'll not see what to do. It's either we'll modify it, we change some things, or we just remove it, or we can now look for something else. Our own is that at the end of the day, we should be able to get the desired result. That is the thing. So sometimes you see a code that have about 30 lines. Don't be afraid. All you need to do is to look at what applies to you in that code and see if you can make some changes so that those code can run for you too. If it doesn't run, you can always remove it. You can use a comment and comment it out, and you continue your work. So please have that in your mind so that you don't see that there's somebody that is a super scientist somewhere. We are all doing the same thing. We are in a community learning from each other. So I will also be sending some of the ways I get projects online, and also how I solve some of those projects online, so that you can also be co-opted into the community. But before that, you should have been able to start doing your project to show that you have some level of commitment to what you are doing. Okay, so let's continue. So we'll run the first line of code, and when we run it, by the time it will give us the number, it means that the code has run and the code is okay. Now this code has run and it's okay. The only thing it's telling me is that program blowfish has been deprecated, class algorithm blowfish. So it's telling about something that may not be working in future, so that we'll take note. So that is what is there, but it doesn't mean that it has not run. It has run. Okay, so the next line now is for us to do what? To load the data set. Data set we are using is hard-disk data set. That is the data set we are using. If you have watched the last video, you see how I was able to bring the data set I'm using into the Jupyter notebook environment, so that I don't need to quote the source where the part in which the data was taken, where I will use C / name / until I get to the CSV file. So we can't do that once we have done this. So I'm bringing it, so I will only use, since it's a CSV file, I will now write pd read CSV file. Now I also ask the system to drop NA. If there's any null value, you should drop it and just give me the first 2 lines. That is what I've asked the code I've used to do. So when I run it, it will not give me what I've asked. I've asked for what? Just 2 lines of code. So the role is just 2 column, just 2 rows. So you can see that we have ID, age, sex, chest pain type, resting BP. That means your BP when you are resting, and fasting BS when you didn't eat and you take some test, cholesterol level, resting ECG, then maximum heart rate, then exercise, angina, old peak, ST slope, and then where the person have a heart disease. So remember, in the last work we did, Titanic Survivor, it was all about predicting if there was a survivor or not. Before we started our work will not always be going that way. Some work we need you to just do what we call clustering analysis. Remember, we treated supervised and unsupervised learning. So in clustering analysis, we are looking at unsupervised learning where we don't have any label of telling us whether there's a heart disease or not, and we can still go ahead to get important visualization, and we also get insights which can be used for decision making. So we have seen that. So the next thing we are doing is to print. You can print, or you can just write the data frame, the data df.shape, and to give us the shape. Here we are asking it to print the record for the shape in, you remember, our axis 0 and axis 1. So the shape is what is going to give us. It's going to give us the shape for the columns, and the shape for the rows. So rows is always 0 and column is always 1. That is the axis. So when we run it, you see that it gave us the row first, because that is what we call record. Rows can also be called record, and column can be called feature. They are the same thing. So whatever you have put here is what is giving you out here. So that is what we have been able to do. So we can tell us that you have 13 row and 13 column and 918 rows or record. And this record, we can prove it. Let's go back to our data set here and try to do Control Shift down, and you see it is 917 plus. Remember, it starts from 0. The ID started from 0. That is why it's 917, 918, and this is 919, adding the top column. So that shows that what we have said is correct. You see, there's an average, there's a count, there's a sum. So let's go back to our work. So the next thing we want to do, we want to see excuse me, the top leagues. That is what we are defining now. And the top league, we want to base it on the chest pain, the type of chest pain. So we roll out our code to obtain this. So data frame that we're using is the chest pain type. So we are going to get the value count. Then we're looking for the largest 4. Remember, I did this before our work on Titanic, before the survival dataset analysis. Able to pick the largest using the n largest code, and we are using index. So we say display the top league. Then we're also trying to define the size. You can always change this. This is the length, this is the width, and this is the height. So depending on what you want to see, you can always change it. So we're also using the seaborn. Scatter plot is seaborn is what we are using. So in the scatter plot, we are using the age. Just watch what we are doing. The chest pain type we are using is exact spelling of what it is in our data. If you change anything, remember Python is case sensitive. It will give you error. It will throw up name error, and your work will become problematic until you arrange it. So for age 2, age is capital A. If it was a small a, then you're working with small a. Then Y is cholesterol. We are looking at cholesterol. So we are plotting the age on the x-axis and Y on the right, on the y-axis, the cholesterol on the y-axis. So we have set up the requirements. After that, we now name our title, because we want our work to have title. So we use plt.title. Remember, when we give our naming in matplotlib diagram and in seaborn, especially in matplotlib, this is how we use it. plt.title. You give the title you want to see on your work. Anything you change here will also reflect here. Now you put for the X label, you want age to appear there. For Y label, you want cholesterol to appear. Then you also want legend, those write-up that are inside of your work. It will come out. Then whatever you need and the location, you are the one that determines. Location is upper left, so that is where you see it. Then you now use the last thing, you say pat.show. If you don't put that pat.show, it may not show you anything, though it will run, but it will not show any diagram or any figure. So after we have done that, we'll now go ahead to do what? To run it. So now that we have run it, you can now go there to look at all that you have asked it to do is what it has done here. So you can see the age versus cholesterol for top 4 chest pain. For people that are in the first of the 4 people that have serious disease, top 4 is what we are seeing. And the those to feel for different type of people, also different type of challenges that come from the chest pain. It's able to be shaded like this so you can see it. And we'll use a CSS, which is seaborn. That is why we have different coloration. Where it to be matplotlib, maybe seeing just one color, maybe blue color. So seaborn makes it more lively and more sweet to behold when you are working with seaborn. Now the next thing, remember, this is mostly disease visualization data set. We want to see more of visual. We are not interested in a lot of coding, even though coding will bring out the visual, but our aspect and our interest is on the visualization. So we're using scatterplot using plotly. Now plotly is another kind of visualization that we are going to see. We have not done that before, but you see how it looks like. So you import it, plotly.express as PS. Even though it has been imported at the top before, it will not alter whatever you want to do. You can see it here, import plotly express as PS. As long as it's already there, if you like import 100 times, it's just for you to emphasize it. Maybe as you're teaching, you want people to know the stage you use, you can put it there. But if not, that one that is on the top is enough for any other work you want to do that regards that plotly. But we just want you to see that this work will use plotly express. So it was brought in. Then we now name our figure. Figure is ps.scatter. Now you are not setting the code. So we are looking at the data frame. That is the argument. Whatever is inside this is the argument you are bringing up, which is the requirement for this plotly to visualize. So it needs you to bring in the data frame. That means this df now will bring everything that have to do with this data frame that we brought up here. This data frame that we brought up here, everything plus the 913 row and 13 column, now 18 row and 13 column, everything is what we are bringing by calling up the df. So the df is coming with everything it has into beer. So we are now going to do what? Plot. We are plotting cholesterol, the cholesterol reading, or the column that has cholesterol. We are going to plot it on x-axis against age. Now we are going to use color. In color we are using the sex, which is male and female, to differentiate. Now we now figure update layout. We are now defining how we want the width to look like and the height. This is we defining. If we don't define, it will come with its own default, and that is what it will display. But if you have defined, it will not assume what you have defined. So we'll run it. This is what we are seeing here. The age is on y-axis and the cholesterol is on x-axis. If you want to change it again, maybe you want to change the age to this place and the cholesterol to this level, it is just for you to go to your coding and effect those changes. Just say x is age and y is cholesterol, it will automatically change. So all we are doing here is plotting this just to show how it affects male and female, and you can see that the blue is for male. So if you carry this your graph, that is where plotly express is different from other graphing. By putting this cross map here, you can see that we're showing that the blue is male and the cholesterol level is 304 and the age is 77. Of course, you see the age is going up. So if you come here, you see a lower age, 29. You come here, you see a moderate age. And if you go to the below, you see a female cholesterol. So it's giving you a form of information as you are clicking. So you can also use another tool which is Plotly Offline. So from Plotly Offline, we import iPlot. It's another visualization tool which is gotten from the Plotly, but it's Plotly Offline. So you set up your argument ps.box and x is the data frame age. So you are only putting x, then you label x as age, then you put the title. You want title to appear, so title will appear. Then you now put up the display here. So you now say iPlot to show you the figure, and you run. So assuming you want to do your work, excuse me, and you want to use the same code to apply to your work, all you need to do is to copy this code. When you copy this code, bring it to your environment, change the things you need to change, ensure that you don't change the argument. So if it's what you are doing is not age, what you are doing is maybe on distance, you will now remove age and put the distance as it is spelled on your data, your data set. Then you set your label, what you want to see in the x-axis that you're working against. Then you put your title and you run, and it will appear there. As long as your code is correct, it will give you an answer. So let's run this and see. So you can see that you say title is 5n, number summary. The way you put it is how you are going to see it here. That means when you do a mistake and write up, it will also appear the way you wrote it. That's why we are careful when we write. I will look at it a second time. And the label is age on x-axis. So when you go to your x-axis, you see that age is appearing there, and the age is all, there's nothing appearing on the y-axis. So when you place this your cursor, you see minimum 28, maximum 77. Now it is giving you the average 54, which is the median. Now you can know what we're talking about median in statistics, mode and mean. But for median is a class, is the middle class. Mode is the class with the highest frequency, and mean is the average. So median is a middle class and it's 54 years. You know, I was talking about 53 there about being the moderate when I was showing you female in the work we just touched now. Now it's giving you the Q1, which is the first quartile, which is 47, and the second quartile is 60. So that is where our average is. So we can see that by plotting this graph. Okay. So the next thing we want to also look at, other things. We are still using the Plotly Express, and we are using scatter plot, and we're taking up all of our data frame. Why I'm saying this is that you understand it the way we remember we said that Python is almost a human readable language. So the way we are saying it is the way it's appearing. So it makes understanding easy. Unlike JavaScript and C++ that you will have a lot of coding that doesn't have any relevance to what you are doing. And by the time you finish, your head will knock. Maybe I will show you one of the work I saved in Java in JSON file, and you look at it and see how you can make out some sense out of it. Compare it to what we are seeing here. See that it will be a very, very difficult task to overcome. So we are talking about the figure we want to see, which we will define as fig, we say it is equals to px. We are now calling the what we want to do. We're using plot_layers plus dot scatter. Scatter plot is what we want to use. And now this bracket here that will end here is giving us the argument that goes with this kind of plotting. Is the argument that you always see when you want to do this kind of plotting. So all you need to do is to pay attention to the requirement of the argument, what it is telling you to do. Please do it. If you fail to do it, it will be putting up error. It will not allow you to move. So it is telling us that we need x, and our x will say, okay, let our s be cholesterol. So since we are calling this cholesterol in the right spelling, it means we are calling up the cholesterol in our data set. We want to pick that column, and whatever is in that column, we want to work with it for x-axis. Then for y-axis, we are picking age, and the spelling should be correct. Now for the color, we want our color to reflect chest pain type. So we have 4 types of chest pain. So we want it to allocate 4 types of color based on this chest pain type to answer our question on cholesterol and on age. Now the size we want to use is the size of maximum HR, maximum heart rate. You can also put other things and see how it will interplay. Sometimes the system will tell you this one that you're putting require you to put an integer or a float. Remember, integer and float are numerals. They are numerical numbers. One has decimal place, one has and doesn't have. And I have not told you that they will have what we call a complex number. Complex numbers sometimes have in between numerals and some alphabets, but they are really complex number. So there's some algorithm that will allow you to use that, but not all. Now the size is this, and the maximum size is 30. Now the hover name is heart disease. So this hover name, maximum size, color, y and x are always there in the argument of this PS scatter. So whatever you put here is what you get with your data set. So if you have a different data set, you can determine what you put there to represent this, so that you can get your required answer. So after you have done that, you define the size that you want your layout to look like. Then you also give the title of what you want to see. Then you now go ahead to run. You can also, in place of going here to run, you can do Shift Control Enter. It will still run and give you answer, so that maybe if your cursor is giving you problem, it will not be an end of the work for you. So you can use Shift Enter, not Shift Control Enter, Shift Enter, and you get the answer. So this is it. Remember, we were putting a color based on 4 things: the chest pain type, ATA, NAP, ASY, and TA. So each of them has different color. So by the time you put up now, you see all the argument you have done. This is chest pain type, NAP, cholesterol level 564, age 67, and the maximum heart rate is 160. You can come down and look at this green, and green is ASY, and the cholesterol is 117, and age is 38, and maximum heart rate is 134, and so forth, and so on and so forth. So that is how we have been able to. And if you look up again, you see a lot of tools. That is for this particular visualization tool. You can download here. You can snap it as a picture. You can zoom in. Let's click on zoom in. You can zoom in on this work, and okay, this is where you can zoom in, not here. Here you just zoom, but here you can zoom in and zoom out. So when you say you want to zoom in, you see it is zooming in. It is zooming in, so that maybe I cannot pick something I wanted to see that is very hidden, and I can also zoom out. zoom out to bring it back to what we saw. This is what it was. You can still zoom it to become very small. So it is at your discretion. This is auto scale. You can reset axis, among other things. This is what is obtainable. So we are just looking at it. When you import it into your own system, you can do all this without any problem. So we want to also look at the using PS cut again. Want to look at the data frame with a different view set, age for X axis, Y for cholesterol, the pain, among others. This time around, want to see over heart disease. Then we define what we want to see and how we want it to look like. So run it. Remember, we say this is mostly heart disease visualization dataset. We are basically concerned about looking at things from visual perspective. We have different kind of audience, and your audience and your stakeholder and the people that have interest in your work is what determines the kind of data set that you produce. You don't produce data set because it's looking sweet and nice. If the people you are communicating to are not conversant with your language of communication, discover that you have not done any justice to your work. When you meet technical audience, more of your work is giving them the technicalities of your work subsequently, just in summary, because I'm also going to make a video of how you produce your project. For remember, we are now right now on Python environment. We are coding, we are generating visuals, we are generating insights, and we are going to use all of them to make our final conclusion. But our final conclusion and what your stakeholder will be looking at is not this your Python notebook. No, they are looking at a summary work, mostly done on PowerPoint presentation. So you must know how to bring in the PowerPoint and what you are going to write and how you are going to use your template to make it, to give the story and to do it in a very, very convincing manner. So this is cholesterol versus age again, looking at it from different perspective also. Okay, so we'll now go again to look at another visual that we have there. So this time around, we're looking at let's run it and see, because we explained some of these things already. So rather than using maybe the 4 types of heart pain, we are looking at heart disease from 1 to 0. Remember, we have either 0 or 1. So we are looking at it here. So ASY for instance has cholesterol 877, and that one had heart disease. That is why it is yellow. And this one is NAP, is 74 years. The maximum heart rate is 116, and it doesn't have heart disease. Let's look at this one again. Heart rate is 120, it has heart disease. And some can have heart rate that is 152, depending. So this is just giving us a visual and a sign. But because we have either 1 or 0, that is why we are seeing yellow or red or blue. Even though we have this as the lowest and this as the highest, we will not see anything in between. If we have had about 4 or 3, or if we decide to change this particular argument or this setup, let's see, chest type, cholesterol, age, we're setting it against heart disease. the color is against heart disease. Now if we change the color and say okay, let the color be on chest pain type, for instance, let's see if I should say okay, let's change the color to chest pain type and run it now. You see that we now have 4 distinct color. See, we have 4 distinct color now, so we have no more 2, as the case may be. So you know, the idea of visual is for us to actually see which visual. We have generated a lot of visual in presentation of your project. You not use all the visuals you have projected to explain. Now there are questions that should arise that prompted you to go into the research in the first place. Those are the questions you should focus on, even though you may have a lot of answers to other questions you have asked. There are subsidiary question or supporting question, but your target is on your main question. That your main question is where your tick is. So in answering question, you be very, very instructive that you have your mind focus on the question that answers the puzzle that made you to go into the research in the first place. So this is some explanatory of what was done, which I expect you to read and understand. Then also look at the other visual again. We using data, hover data as old peak, and the color now we use sex, so it will be 2 color, male or female, and height is defined. Then it is age and cholesterol, because mostly we are arguing that, or we are sensing that, or we are thinking that the cholesterol level is also a problem, especially as it gets to do with age. So how true is it? Now you can see we have more male than female in our work, and this is how they are rated per number in the cholesterol level rating, among others. So the ones that are age 70, you can see the level of cholesterol, that is 77 male, and the cholesterol is 304, and this 54 male, cholesterol is 239, and old peak is 2.8. So I've been able to have a visual about that. Now as we continue to progress, we see that we are trying to do other things outside of that. This definition, define, is not kind of a method or a class. It's just a kind of coding, or where we generate something that we can always go back to use again and again. So instead of anytime we want to work, we'll begin to write fresh code, and after it will run. When you have done define, anytime you bring it up, it will still give you the same result as it was. So here, our definition will say generate rating of data frame, and the data frame we are using is DF. Take note of this DF. This DF is the DF of our work as it is contained in our data set. Our work as is contained in this our data set. That's what we are saying here, as it's contained in our data set. So all these things we call it DF. So that is what is here. So the rating DF, which is we're not defining our work, is equals to df.group by. We are trying to group our work. Remember, we did group by, we did aggregate function, so we are grouping by. Now we're calling up a list. So in the list, We say chest pain, that's 1. We're talking about ST slope, that's 2. Now we're aggregating them by what? By the ID and by the count. So we're using it now and resetting our index. Index is the first number. Looking back again at our work here, we see that let's go back control. We see that this is our index. The ID will start from 0, but this is the one we set up. But to see the index proper, we go to what we'll call up. This is, we'll go to where we'll call up our work. Here you see that we have index 0, index 1. So now this place has nothing, and that is where we are headed to. We are heading to that place. And what are we doing there? We are going to reset our index with respect to the ID and count. Now rating, now you're bringing up the ID and you're defining it now. That is not the same thing as 0. Then you are also working at the column, chest pain, and the slope and the count. And now you're also resetting it again now to the values, and you are sorting it. You are sorting this value. So once you have done that, you are now going to bring back our DF, which is our data frame. Now the next thing you are doing now is to do what? To plot whatever we have done. And in this plotting, we are saying that the chest pain should be on the x-axis, the count should be on the y-axis, and the color should be of the ST slope. The position should be automatic, so the system should pick by itself where it is necessary to place whatever you want to place. And the font of the text should be 20, and the layout should be stack. So after you have done that, you will now run your work. So this is your count. So that is now your index, and this is your chest pain type, and the ST slope is what you have used, and it is arranged as stock, just as what you have said. Whatever you have said there is what is going to appear here. So the next thing is, we're almost using the same argument again with some changes. When you look critically or carefully, you can be able to pick out those changes. This is stack. Remember I told you in data science and in coding, you can copy and place. It is even more better because when you type, you can do typographical error, which will keep you where you are. So here we're using group. It's almost the same code. We're just changing the bar mode to group. The other one, the bar mode was what? Bar mode was stack. So let's see how it will look like using the group function now, or the group now to get our work. So now it descends down, flat and up, but now it is now group in a bar. So this is in group. This is for ST slope down. This is for slope up. When you look at this one, it's up, up, up. This is for the flat. When you go up, you can see that it's for the flat, showing there. So the next thing again is to look at it again from another angle. When you look carefully, you see what has been changed. Bar mode is still group. Now text is count. You are now adding text to it, to what is there. Just one step, just one thing has been added. So we'll look at how it will. So you see the count now, because we have put the count, you see it is now giving us the percentage of each on top. So all these things are steps in teaching you how to become a data scientist and how to code and what is entailed and what to add and what not to add and when to add and when not to add, so that it will not be too difficult for you to work. So now we are looking at a different thing now. Fig is equal to, this fig is equal to is always what we use to define. Sometimes you see an error coming up, you say this is not defined. That means something has not been equated to it. But whatever you are equating should already have been existing in the system. If not, it will see throw it out. So fig is equal to pa.scatter, and now we're using data frame is equal to df. So we are defining our data frame. Remember, data frame again is why we brought in the pandas as ps as pd, and data frame is anytime you see row and column, we're talking about data frame different from just one dimensional work. So we have x column as age, we have y column cholesterol, we have color on chest pain types, which are 4 of them. We have size, maximum heart rate, hover data, we have old peak, then the marginal, we are using histogram for x-axis, and for y-axis we are using box. You see combinations of work here. Now the update layout, trying to give a title this, and the font size is this. If you reduce it, the font size will reduce, increase it to increase. So the family is serif. All these ones are the argument already set in there. These are the ones you can manipulate. The name you can change among others. So title you can change and write what you want to write here or what you want to use. Then you now run. So this is what you see there. This is age versus cholesterol. That is where we have that font size 20. And remember, these are our handy tools are all there. So you can see chest pain type, ATA, age is 54 to 55, and the count is 28. As you move, you get different values. Now when you come here, you see different rating again, and you also see different rating. This for ATA, this for NAP, this for ASY, and this for TA. These are for the what do you call it now, the chest pain types. So for here now, also changing something. Instead of I think sex has been added and something was removed. Let me check up and see. Sex has been added, an old peak was removed. So let's see how it will look like when we now introduce that. Remember, we are looking at visualization, so we do a lot of things and see what it gives us. Okay, so we are looking at this age, old peak, okay, this is what I want to run now. Want to see how it will look like. So like here you can say, can even change the title. Since we are using sex, you can say age versus cholesterol and versus sex. You can do that too. You have to have something that looks like age versus cholesterol, versus sex, for instance. I'll run it. So it will now add it up there, maybe to give a different dimension or different understanding. So we also use other things again to run up this one. Let's also see what this gives us. Age versus cholesterol, and also the gender. And if you look, I think there's something there. There's this line that is there. It's an average kind of line. We have it for the one for the male and the one for the female, picking up the average or the trend line. So all of them are calculated or incorporated in the formula that we used in running that particular line of code. Now you see it is more clearer here because it was done with a black line. So we'll call it overall trending. Now this trend line now is for both the male and female. So the trend line will show us an average, sex, female, age, cholesterol, among others. So this is the average trend line. See, its color is black, unlike this. So it will give us 1 rating. No matter where we get it, if it is black, it should be 1 rating. Ordinary square trend line, cholesterol is 1.10, age is 257.9. The R square is defined, average age is defined, and cholesterol is defined. This is what we see on this trend line. Okay. So now we are trying to do another thing again here. So histogram, now I want to plot out a histogram to see how it looks like. So histogram of person by age is what we call it, and the female is on top of the major like a stack, because male are more in number, so this female are put on top. I will try to see how it looks like. But what brought about this is the code line. And you can see the length of the code line. You define what you want to do, what you want to plot, the age, whatever you want to see in the age is what you define here. The color for the sex, then the purple and pink is what to put there. Now what we are saying, if you desire, you can change it to blue and green. You can also see it here. So fig update, you write the name what you want to see there. The font size is 25. You can also change it. Title, fonts, family, time, the type of font you want to see, you define. If you want to see Garamond, you can also write Garamond and remove Time New Roman. The title, font color, everything. So whatever is going to come out there has already been defined here. So that is what we do in coding. Whatever you have defined is what you see. So if you don't define it well, it may not come out well. So we're bringing in Plotly again. Now this time around we are bringing graph object as GO. Graph object is coming as GO. These names you are seeing is not us that gave it, is a convention name, so that anybody looking at your work, or you too looking at your work after many years, will not be confused. So you go with what is in convention. Then you also make subplot. Now I want to make some subplot, small plot that are plenty, and the things we want to put in is what we begin to fill in inside our argument. Remember, the chess pane type is 4 type: ASY, ATA, NAP, TA. So we use the argument data frame. Now we now call the one to want to see. in that data frame, the chest pain type for this one should be ASY. The same thing for all of them. So you begin to bring out your plot, and you want to see 2 row and 2 column. That means 1 1 1 1, 2 in the row and 2 in the column, or 2, just 2 by 2 matrix. So you begin to define what you want to see, and the subtitle you want to name. All of them are there. After that, the figures now are named with whatever you want to see appear in those figures. We want to see sex appear, we want to see the cholesterol level appear, and where the position they want to see them: position 1 on 1, position 1 on 2, position 2 on 2, position 2 on 2, just like row 1 column 1, row 1 column 2, row 2 column 1, row 2 column 2. This is simple what we have just done here. So after that, we define all what we want. The title is defined also, and the size of the font size. Then we'll now run it. Now that is how it's coming. Remember, the sex there, male and female, is their comparison. For this cholesterol distribution, we are seeing that female are 17.8% and male are 82.5% for here. This one, you see the rating for male and female, and so forth, and so on. So that is how we are able to do that. We can also use the same and change some things and look for something else again. The same thing that we have coded, just maybe one line of code or one name. Like here, we are now putting this resting ECG here instead of what was there before, age or sex. I will now run it to also have a view. You see, resting ECG have normal, LV and ST, so you can see the percentage instead of seeing male and female. So this particular line of code was giving me headache, so I have not finished it, so I just left it. When you call it up, there will be some error, and still working on it. Remember, I told you data science is all about cleaning and cleaning, trying and trying, and continue until you get your answer. So because we have not gotten an answer does not mean that the work is not good. We can keep it. I may have decided to just clean it, just delete it. Somebody will see it. Then it looks as if every work we do in data science is as smooth and clean as like that. No, that's why I left this here, but you can just run it over. That's why I comment on it. Now, how do you even comment? Let me teach you how to do comment so that it will be easy. Just let me start from here. When you have captured everything, come to Shift Control. You see question mark in your laptop, just touch on it. You see the code has come back. You can run the code and see whatever it is there. But if you don't want it, or the code is giving you problem, it's throwing up error which will affect your work, you come again, click on, just highlight it like this, touch and click Control question mark, and all of them are commented. So once all these ones are commented, you just run it, it will just pass. So it will not affect your work. You continue what you are doing. So that is the option you always have. So these are the things we do as data scientists to make our work easy. So now we are also bringing this IP plot to look at other things. Here we are looking at, we are using gender for data frame. We use value count to count the number. We now, the moment there's no gender there, we are the one defining this gender, and the gender is coming from data frame, which is sex. That way we're getting the gender. Now we display gender head, put it to frame. So we are taking this gender head that we're getting, male and female, that we'll get from the gender, which is in sex, to frame. Then we'll now begin to shut off our bar using PS, which is Plotly Express, and we'll define how we want it to look like. So the frame itself is now gender, which is what is here. If what is here, this is what we have defined this. After defining it, now we can able to use it here. If we have not defined it and we use it here, it will call up an error and tell you that that value, that name has not been defined. So since we have defined it, now we now say x is gender.index. We are making gender the index head from our row or our column, and y is gender. So color, among everything, we define what we want to see. Then we'll plot the graph. See, the gender is sending as sex, and we'll say that those genders should be in the index. That is why it is here, and also have value count. That is why it has counted it for you. After that, it has brought this number into your plot. Say gender, look at the frequency, number of observation, and female, number of observation. So it has done what you have asked it to do. So for here, we are looking at the category chest pain, and also doing value count. Then we are using bar, and in the bar we are defining what we want to see. We are using category divide by sum of the category and multiply it by 100. And now we are going to put up color and do other things. Y is sending as frequency, y as this should be frequency, which is in percentage, and the category is sending as category, and the title now is frequency of chest pain type in percentage. Now the text, we now use lambda, which is a function, to do some conversion for us, and the color we want is dark. That's why we indicated it here. Then we'll go ahead. The size of our write-up should be 20, size 20. So when you run it, see that our background is black or dark in complexion or dark in nature. Can be any color, but we want it to be dark just for aesthetic sake, and you see, define whatever we want to define. Okay, the next thing is we want to also do another thing again. Chest pain is what I define in now, and say we define chest pain as data frame chest plane, and we're counting it again. So before we come to put it in our figure and define the colors, this color now we just give the color code for 3 things. For instance, we want to see, and then we tell him the kind of template we want, dark again, and other requirements. See here, we'll increase this into 600 instead of 5 that we used to see. See, the background is what? The background is dark. Then other things I will ask, like this one is too big, you can decide to reduce the size by going to the code, looking at the code very well. That's okay. Why not bring it down to 400? Bringing this one down to 800. Now run again and see if the size, see the size has reduced. So if this size is okay, other algorithm we can do to also increase this size inside to become bigger than what it is. So all of them are there in that code. All you need to do is to observe very well and study it, understand it. Sorry, I have cough. Now another thing again, we are still using the same data, chest pain type, value count. We are doing other things. So all you need to do is to understand what is being done, and we run. So here we are using horizontal bar chart to show the different level It's the same thing we are still saying in different way. So you can see that we have 54% as ASY, 22% 18, and this one should have been sort. Let's check the formula. Should have been sort. Show legend, yes. Okay. It was not sort, but it will take up this took up by default, took up the ascending, which is the highest to the lowest. But in most cases we see sorting. So this one too has problem, we'll leave it. We'll go to this. See the distribution. Plotly Express will bring this. We also bring iPlot. We bring objects and subplot. So what do we actually want to do? We'll make subplot 1, 2 subplot title age distribution. So we are making a comparison now between age distribution and log of age distribution. So figure we append. You remember our appending? Our appending, we append to form a histogram. We're using age, and the place we put this one is in row 1 column 1. Now the next one, figure we append. Now look at what we're appending. The first one was age. Now we are appending the log. See the log of age. So it will, you calculate by yourself and get it, and we'll name it log age distribution. And see the position of this is log column 1 row 1. This is column 1 row 2. No, sorry, row 1 column 1, row 1 column 2. So when we run it, we see the position. This has a position. Assuming you don't want to see it in this way, you can come here and say column row 1 column 1 row 2. Let's see. You know, in this work you always try a lot of things. There's no harm in trying and see how it goes. Let's run and see whether it will give us an answer or it will throw up an error. It's still running. Let's see what it will give us. Now it has given us an error. Let's trace what the error is saying. Say the row column percent is out of range. Use figure print. So that means the argument that is given was contravened. You know, I told you there's some particular argument that are there which will follow. So those arguments follow it the way it came, and it will not have problem. So this one will not agree. So what we'll do is we now reverse it again, so that it will be on the line of argument, and you run and you get your answer. So the next one again is we're importing NumPy, we're importing plotly graph and offline iPlot. Now we're going to calculate the quartile and interquartile range. Remember, quartile, 25% quartile range is defined here for cholesterol as Q is equals to 0.25, and for 75 quartile range is defined, and the interquartile range is the highest was lowest. So the cutoff now, what we are removing will be interquartile range multiplied by 1.5 for the two sides. So we are picking this, the cutoff is what we are picking. The other ones will be left behind. And now we are now going to print outliers. We want to see what are the outliners. What this code is to bring outliners to us. So we'll now put up our line and the rest. So let's run the code and see. So some function will be duplicated, or some functions are already duplicated. So group bar plot for age and cholesterol for top 3 type of chest pain. We're not looking at all the chest pain now, looking for the top 3. So the TA is not here. So we can see how it is defined. How is defined? So what we have done so far is looking at visualization of a data. We didn't go to the extent of running our model, testing our modeling, and also coming out with a conclusion among. It is not in all cases that you do that. It is not when you do that you are a machine learning expert. You have a lot of things you are going to do. You are going to learn logistic regression. You are going to learn regression on its own, which we have seen. We are still going to bring more. We are going to see clustering analysis with other type of clustering. We are going to see high-tech visualization. We are going to see the work with Peak API amongst others. They are very, very vast. So it's just a stepping stone. So all you need to do is to get yourself acquainted with what you have seen, and you continue to build. I think I also do a class that will teach you where you can go and get other resources that can be of great help to you. So having done that, let me just clear my output and run it again one more time, so that everything will be on the same page. Okay, it's trying to run. Look at this place to see when they start running. Okay, so in addition to this, today it has started running. You can see some movement in the system. You can see this place coming up and coming out. That is showing you that it's running. And you also look at up, you see that the notebook is closing and opening. That is, it's running. Yeah, I think it has finished running. So the next thing I want to teach us today is how to use other source of body of work to also do a Python work. Remember, we'll have a Python shell. Let me go back to my back end to show us something. Yes, when you come here, when I was trying to explain this starting point, I was able to come here. You see, we have Anaconda Navigator, Anaconda PowerShell prompt, Anaconda prompt, Jupyter Notebook, Spider, amongst many. And I was able to teach us how to use this Jupyter Notebook and Anaconda prompt. I did not show us how to use Anaconda PowerShell. The reason is that the PowerShell is a different ballgame altogether. The codings you call up, the libraries you call up using the Jupyter Notebook may not be possible in the same pathway with PowerShell. So I said not to pursue it, so that not to be cladus. Some of them you can try it on your own to see how far you can go if you have known the basic. Now there are other ones too you need to know. They are important and they are becoming very strong in the market, so it's good that you have idea and you can pursue it succinctly, gradually, not with all your power. Now I told you Python have a strong competitor in R. But Python has overcome R many years ago. But for the Python, it is not only in Jupyter Notebook in an Anaconda environment that you can use to code. You can also use what we call Google Colab. Google Colab. You can search it up on your Google platform. Google Colab. It is an internet stuff which we use to do our data analysis. It is the same thing like Jupyter Notebook. Then another one again is Azure Notebook. Azure is also an important, a strong application tool for data analysis that is brought up by Microsoft Group. You know, this is competition and it's a business competition, so nobody is relenting. So there is always improvement on a daily basis. Everybody wants to take over the market. Google is bringing Google Colab that you can use to run analysis, and your work can be stored on the cloud. You will not lose anything. Yes. And Anaconda, which is not the owner of Jupyter Notebook, decided to bring up a space and allow Jupyter Notebook to be run. And meanwhile, Jupyter Notebook is all about Julia and other forms, Python, and one more group. That was the main thing that was being put in focus when Jupyter Notebook was produced, so that people can code with it. And Python itself is a mechanism that applies using Jupyter Notebook. So Jupyter Notebook makes Python easy to use, and other platform also uses Jupyter Notebook. So machine learning can also be done using other platform, but Jupyter Notebook, Python has made it easy to be used. Now Azure has also brought up its own environment. So I want to show you how you can also use Azure to do the same coding that we have been doing, and you can also be rest assured that your work will be safe. So remember when you were downloading and saving your SQL, Microsoft SQL, at the back end, after it has saved, at this back end you see that there was Azure Studio that was part of what you saved. That studio is what you are going to use. So I'm clicking it to open it up. So let's open Azure Studio. So let us see how we can be able to do what we have been doing using the Python or the notebook that is in Azure to do our coding, and also how to save it, because it is very, very important. And the difference between the Azure notebook, and the, let's keep waiting to open. The difference between the Azure notebook and the Google Colab is that Google Colab works the same way that Google Network works. Everything, you will need internet to work with Google Colab, but once you have done a work, your work will be saved online. Once you have done any work, that work will be saved online, so you can use it anytime you want. Now for the Azure 2 is just like our Python environment or Jupyter Notebook environment that we have in our work. So the challenge you have is that once your system has a problem, you may not be able to get access to it, even though there are a lot of things you can do to recover them if you have leaked online, because they have a platform where you can pay, and when you pay, you are exposed to their server that can store your information. As long as your email is working, you will recover it, but you know it involves money. And people that don't have much don't always spend too much. So this is the Azure environment. So once you have opened it, this is what comes up, and you can see the platform. I don't need to begin to explain everything one by one as I did at your kindergarten level, but know that this is a powerful studio that can be used for many things. You can see deploy a server. Remember, there are other kind of interaction like DevOps and DevSecOps, which use bigger studio internet. You can be able to leverage on it here. You can create connection, you can run a query, you can create a notebook, amongst others. So this is for new connections. You can always do one or two things here. So my attention is on this creating a notebook. So you come to this create notebook, click on it. It will give you, open up a new platform. Now if you want to use it, you can use this particular space for SQL, which is structured query language. You can use it for PowerShell. You can also use it for Python. So when you want to use for SQL, for instance, you open it and go to your SQL server and copy the server license or the code name, and when you bring it up here, it will open for you to work with it. But what I want to do here is to show you how you can use it for Python. So you come here, you see it's already on the kernel of SQL. You just click on it. It will give you an option whether you are going to use it for Python or for PowerShell. So I click on the Python. When I click on the Python, it will change the kernel for me. So all I need to do is to wait for it to change the kernel. So once the kernel has been changed, I can now go ahead to go to this work that we just finished now and see how it will look like. We'll touch one or two of them and see how you can able to use it and to code. Maybe we can go down to one or two visuals so that it can guide us. So you know how to do that, how to save and how to retrieve your work. And once you're able to know that, I think you are good. Now you are good to go. Now you see our Python 3 has come up, and you know it has its own local host. So now the next thing now is for us to run a code. So now observe what I'm doing. I'm going to click on cell. So I put on text. Now what are we writing? We are writing heart disease, the name of the heart disease visualization analysis, for instance. So after you have written this, you see, unlike Python, you can come here and Control B and make it sweet. You can even come and pick the size you want, maybe very big size. You can do a lot of things here as you wish. So you know it's not a code, so it will not code it. So the next thing now is you come and click on the plus. Now I want to now do code. So code is the next thing. So I come to this work that we just finished. I just go up and copy it. All this English that you are seeing here, pay attention and look at it, and we'll come to our Azure and place it. Then we'll come here and run it. So it has run. See all the issues that came up, and it tell me that it's Python that I'm running. If it were SQL, you will see SQL. If it is PowerShell, you will see PowerShell here. So if I have done this, I want to run another code again. I will come here up and just click on plus and go to code and click on code. I will go again to this place and go to the next line So once you have already saved this to Jupyter Notebook, it doesn't have problem. It will follow suit as you have saved it there. And you come here, Ctrl V. So I've loaded data set. Your comment is on green, just like in SQL, and you run it. It has run because you say you want to. Assume you don't want to see all the line of code, you just come here and just click on it to just give one line of code. It is at your discretion. You want to be seeing more of what you are doing, and you come again, you say you want to add more thing. So what do you want to add? You look at this one. You want to add what? So you want to add what? You want to add copy it. It's a code. So come here, Ctrl V, on it. Come again. Want to run another code. Come here. And we'll pick up the code. Our target is just to get 1 or 2 visual. Then you can do that yourself too, based on the dataset, which I'm also going to send to you. So we'll run these two. So each code is run on its own cell. So we can see the visual here. Okay, the next thing, is to put this visual too. Okay. So go up a bit so that I'm able to put up close, add another code. So run this code. So the code also has run. You can see the visual. So you see that it is the same thing that we are doing in the Jupyter Notebook using the Anaconda, that also doing using the Azure cell, and you can also run all at a time, just the same way we run our work. See how it will run everything. To run everything for you and give you clean code. So after you have done this, so you can also know how you can save your work. Also increase this you want, so that your work will not look scanty. So to save your work, you go to File, you click on File, you come down to File, you go to Save As, click on Save As. So when you have Save As, it will let's cancel and move away from here. Let's go again so that you can see what will come up when you put Save As. Normally it may start from showing you just the normal this thing. In case if it didn't come up, this is showing from the hard from my C drive is going to Jude to iPhone, and I'm saving. So have an iPhone data under the work. So when we come to the iPhone, I can now save this. Wanted it to take us to this name is popping up. I can say no, I want to save it as heart disease visuals, and they will say save as type, showing JSON file. Please don't leave it as JSON file. Now you come here, click on it. Also don't leave it at Python. Go to notebook, leave it as notebook, and you save. So it will save as notebook. Now look at what will happen, assuming you save this work as a JSON file. But now let's close it. Okay, as we close it now, we want to bring in our file. We want to do a work. You can open up a file or open up a folder. You see, open up a file, it will take you to where the file is. You can see heart disease visual. When you click on it and open it, see the file has opened. So you can continue whatever you have been doing on this file because it's already saved for you to continue your work. That is one. You can also come to file 2 and go to open recent work. You see your recent work here. You can open it too, and it will open, and it will give you again your notebook for you to continue your work. Now this is where we have issue, because I have taken my time to explain this. It's possible that you want to save, as you saw that it opened for me to save on JSON file. And if you have saved on JSON file, let me show you the file that I did that mistake with. You go to recent and come to this. You see Titanic Azure. I saved Titanic work, but I saved it in Azure file. And after saving it in Azure file, now let's open it and see how I want to work. You can see, look at the sign of JSON file, JSON sign. Now this is how it has been stored for me in metadata. And now if you are not trained on how to extract this metadata, and believe me, you'll be here for years, you don't know what you are doing. This is example of metadata. This is the whole work that was done in the survivor that will have it, but because it was stored in a system where we don't understand, or where it is not clear to us now, you can see text file, passenger ID, survivor, P class, X, female, to know that you understand that is the data that we have been using. But how to bring this thing to utilization and the all the manipulation we did are all here, but that is it. That is all to it that we can understand here. So you see that it is difficult for us to work with this. So that is why it is important for us to know how to save our work. Now let's go back to the Titanic that we did, which I wanted to save here, which I have already saved very well. I just wanted to show you an example so that we'll be careful of our saving. Go back to our recent work, open it, then you go to Titanic Survivor Azure. This is iPhone. It's different from just PY iPhone. So you click on it. When I click on it, it will bring up the Titanic work. For it, let's go back and okay, it has come up. Now you see the Titanic work that we did earlier. This is all the Titanic work that was done in Jupyter Notebook and with the visualization. So it's just the same thing. So it is not a matter of choice what you want to use, but you know, it is always good for you to have understanding of more than one tools of analysis, so that in case maybe you are working in a company that needs you to use a particular set, it will not be problematic for you in using that. So you see, unlike a Python Jupyter Notebook where you cannot take in and write, you can do that here. You have liberty to do that because the environment allows you to do that. So this is it. Building machine learning, logistic regression, and the results are coming up. And I discovered that my logistic regression, there was one that the percentage increased. I think it's the Gussan Bay to 70 something. It was an improvement. I was still wondering what happened, why it changed from the Jupyter Notebook to give me a higher rating. So this is it. His Naive Bay was not very strong using the Jupyter Notebook, but under the Anaconda environment, but it was better here. So you see the same analysis, the same coding, the same answers, the same diagram, and the work. And so this is what I need you to know, how to also use Azure, how to bring in your work and how to save your work in Azure. I think we have been able to do justice to our class today, and I wish you well, and also say congratulations. I'll wait the signal for you to have your last project and for you to conclude your work. But in the interim, as I have material that are needed and useful, I will send. I will also teach you how to use PowerPoint presentation. I will teach you how to use Google Collabo. I will teach you how to work on GitHub. I will also teach you how to get material, and also the importance of some social network that will help you. Then Stack Overflow, GitHub, amongst many. LinkedIn will be discussed so that you'll be acquainted with current expectation. And with that, I think the sky is your stepping stone. So I will stop in here. I say, may the knowledge be with you. Congratulations in advance, and bye bye.
In today's world, data is the new gold. Data scientists unlock insights from raw information. They use statistical methods to analyze trends. Data analysts convert data into visual stories. By creating dashboards, they help organizations make informed decisions. Machine learning models can predict future outcomes. They identify patterns that aren't visible to the naked eye. Data cleaning ensures accuracy and analysis. Collaboration across departments enhances data insights. They utilize programming languages like Python and R for analysis. Cloud computing resources expand their capabilities. With big data, they tackle complex challenges across industries. Ethics in data science ensures responsible use of information. The future of data science looks bright with endless possibilities.